Hello everybody and welcome back to Algebra 2 online. So today I just want to talk about inequalities from Algebra 1. It's just going to be some review. And just to start off, I want to make sure we're kind of on the same page with certain terminology. So when it comes to inequalities, sometimes I will say things like x is at most y or a is at least b. And really, all this is saying is an inequality. And so the way I kind of think about the first one is if something is at most y, right, then that thing can't be bigger than y, right? So you can be less than or equal to it, right? And for something like a is at least b, if you think about ages or something, you could say you're at least 1 year old, but you can't be less than that, right? So A is greater than or equal to B. So when you hear me use those words, just think those two inequalities. Another thing that I will definitely say often are statements like number 2 and 3 here. So these are just two compound inequalities, and it's really just like English class, like a compound sentence. You know, you can use the word and to make it a compound sentence, and it's the same in math. And I just want to make sure that you understand how we would graph something like this. So in my class, I don't care about putting anything extra on the number line besides what you need here. So we need a 0, right? And we need a 2. And if you're less than 2 and bigger than or equal to 0, if I do this kind of with two colors, so this part right here, the less than 2 would look like that, right? You don't get to 2, so we do the open circle and then we go below it forever and ever and ever. Maybe I'll use this color. So for greater than or equal to 0, we are equal to it. So we do fill that circle in, and then we go bigger than it, right? And the word and, really the way you want to think about these is that the word and kind of implies we need the overlap. So to work for a compound and inequality, it has to work for the red region there and the yellow region. And so if you look at what that would be, this is definitely in both. And then all this is in both, but not anything past 2 there, right? So we kind of get like a kind of a barbell, dumbbell looking thing right there. Those are the trickier ones. You have to be careful that whatever you're shading, so again, this white part right here is the answer. Whatever we're shading, like this white part, has to work for both. You basically need to shade the overlap of the two, okay? The or ones are not nearly as much work because basically you can be here less than 3 or bigger than or equal to 5, or both. So the ors tend to include more things than the ands. And again, you don't need to put anything else really besides a 3 and a 5 here. And less than 3 would just be that. And then bigger than or equal to 5, we'd shade in the 5 when we go to the right. And you can always kind of like check a few of these if you want. Like if you took the point 2 down here, number 2, that should work for x less than 3 or x bigger than or equal to 5, and it is less than 3, so that definitely should be there. But if you take something like 4, right, 4 is not less than 3, and 4 is also not bigger than or equal to 5, which is why it's not in the shaded area. And you could have done that same thing up here. You know, if you take 1, 1 is less than 2 and also bigger than or equal to 0. But something like outside, like -1, -1 is less than 2, but it's not bigger than or equal to 0. That's why it's not in there, okay? And just kind of another piece here that's super important. So I think a lot of us remember that we need to flip an inequality sometimes, but maybe you don't remember when. And it's really pretty straightforward. You just need to flip, basically, in a situation where you're multiplying or dividing across the inequality by a negative. So I will write out what that looks like. So say we take something like 1 is less than 2, right? Which definitely is true. If we multiplied both sides by a negative 1, right, we get negative 1 is now less than negative 2. And if you think about that, right, if we draw a number line, negative 1 is over here, let's say. Negative 2 is further down the number line, right? So this statement that I drew in red is not correct, right? And so the reason it's not going to be correct is because I didn't flip that inequality. The way you want to write that is just if you multiply both sides there by a negative 1, you just flip that inequality around, and now this statement in purple here is actually correct. So just anytime you multiply or divide by a negative, flip that inequality. So I wanted to just do an example of kind of over here what we might be running into. So if you have any kind of inequality like this, where you have a fraction, I would personally just recommend you get rid of the fraction always first. So in that case, I would just multiply by 6, right? So I get negative 24c is less than or equal to 5c plus 58. Ooh, did that 8. And in this case, I would probably just subtract negative 5c. So that would be negative 29c is now less than or equal to 58. And this is a good example of when you're going to need to be careful. So I'm going to do this in red. So if I divide by negative 29, right, I will have c now not going to be less than or equal anymore. It's going to be greater than or equal to, I think I made this negative. Yeah, that's negative 2. And so that would be the answer. I flipped the inequality and all that. And just to kind of show the graph of it, if we want to graph that, we would just, I only care about the one number, negative 2, greater than or equal to, so we're going to shade it in. Sorry guys, I got a phone call and I lost my place there. So what I was saying before my phone call was this shaded in dot is equal to negative 2, and if we want to be greater than or equal to it, right, we're going to have to be over here. So all the numbers like negative 1, 0, etc., all those are bigger than or equal to negative 2. And that's basically a kind of straightforward inequality problem. I want to just show you a few weird cases in regards to compound inequalities. So I'm going to make a number line for all of these quick. So we've got a 2, we've got an 8 on that one. Here we've got a 2 and a 10. And here we just have a negative 4. And in the first one, we want to shade what is bigger than 8, right? So that. And what is, we'll do this in yellow, I guess, less than 2. And since it's one of the and ones, right, we need to worry about that overlap. And as you can see in this picture, there is no overlap, right? There's nothing in the yellow that's also where the red is. So this is one that also just is no solution. We saw some of those with the absolute value equations. There's some on the homework. They're going to show up. And don't get scared with them because they're a very normal kind of answer that you run into in math. The next one, so if you're less than 10, right? I'll keep with my colors here. So if you're less than 10, you'd be like that. And then if you're bigger than 2, right, you're going to be that. And if you look at what I just shaded there, right, you will see that I actually shaded everything on that number line. So this is kind of another weird situation that shows up. And the best way to really write this answer is this weird little R. And that R is really just a way to symbolically say all reals. So every single number, every real number, there are actually other kinds of numbers out there. We'll talk about some this year. But all the real numbers are on that number line. And all of them work. It doesn't matter how weird they are. Like, you can have the number 1112 divided by 17. That is definitely less than 10 or bigger than 2. You can have the number pi, right? That's 3.14159, blah, 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 blah. That is definitely in that region. That one is actually right, I'm going to say about that. So that one's kind of weird. This last one is probably the weirdest one. So if you're less than or equal to -4, right, you would be like that. And then if you're bigger than or equal to -4, you would be like that. And if you remember this and, right, we need to worry about the overlap. And if you think about it here, the only overlap we actually have is right at -4. So it's kind of a weird answer. Do that in black, it's a little easier to see. So the only answer on this one is -4, because that's the only thing that is simultaneously less than or equal to -4 and bigger than or equal to -4. So all of these are definitely possible. You will see them from time to time in class. So I just wanted to do one last kind of problem, and it's just a way that you will sometimes see compound and problems. So if I ever want to do an or problem, I actually have to write the word or. And you literally just solve this out and you solve this out, and that's it. These ones are not so bad. A lot of times students are fine with those. But up here, if I write an inequality like that, it's actually kind of a hidden and problem, because the way we would actually read this, so we would read 3 plus x is less than 7x minus 2, and this is where the hidden part is. Then it's going to be and, I didn't write it, but it's implied there, 7x minus 2 is less than 5x minus 10. So that one is a little weirder because you don't see the word and, but it is there. So the way I would recommend you do this, split it up. So do 3 plus x less than 7x minus 2. And then we're going to kind of have a separate problem where we have 7x minus 2 less than 5x minus 10. So over here, I would probably add 2 minus x, so that's 6x. So 5 over 6 is less than x on that side. And then we're going to have, I'd probably minus 5x, so I get 2x. And then I'd add 2, so I'd be at -8. So then divide by 2, -4, right? And you just got to remember, there's a word and that's kind of hidden there. The or ones, again, you're always going to see that word or. There's no way to hide that. It's just or. I have to say it. And just to kind of do out the graph of this one, I'm just going to kind of go down here. So we would have, we need a -4. We need a 5 over 6. And if you're less than -4, you'd be in that region. And if you're greater than 5/6, you'd be in this region. Okay? And since it's an and problem, right, you need to look at the overlap, and there is no overlap between this stuff down here and this stuff up here. So it would be another one that would just have no solution. Okay? And that is just kind of a little bit weirder of a compound and problem just because you don't see the word and. A lot of times I will write it just like I write it here, or we wrote it on number 2 and 3 there. But sometimes we'll put them all together like that. And that is about it.